Welcome to 7th grade math. We're going to review some concepts, which operations undo each other, addition and subtraction undo each other, and multiplication and division undo each other. What are the division facts related to the multiplication problem 3 times 5 equals 15? We could restate that to say 15 divided by 3 equals 5, and that's how we could undo the multiplication. Or 15 divided by 5 equals 3. What are the multiplication facts related to the division problem? 24 over 4 or 24 divided by 4 equals 6. We could undo the division by saying 6 times 4 equals 24 or 4 times 6 equals 24. These are called inverse operations. How can you use what you know about inverse operations to solve equations like 3x equals 15? You can use division to undo the multiplication of 3 and x. How can you use what you know about the inverse operations to solve equations like x over 4 equals 6? Use multiplication to undo the division of x and 4 in x over 4 equals 6, or x divided by 4 equals 6. Ready for the lesson? Homework. Shonda spends half an hour doing homework after school. Then she spends another half hour doing homework before bed. Write a multiplication expression to show how much time Shonda spends doing homework. Then find the product. So the multiplication problem is 2 times 1/2 equals 1. And then complete the table below. 3/2 times 2/3 equals 6 over 6, which equals 1. 1/5 times what equals 1? 5 over 1. 5/6 times 6/5 equals 30 over 30, which is also 1. 7/8 times 8/7 equals 56 over 56, which equals 1. What times 5/7 equals 1? Equals 1. 7/5. 2/6 times 6/2 equals 1. 7 over 1 times what equals 1? 1 over 7. And what times 8 equals 1? 1/8. What is true about the numerators and denominators in the fractions in number 2? They're switched. Multiplicative inverse. Two numbers with a product of 1. Also called reciprocals. So inverse property of multiplication. In words, the product of a number in its multiplicative inverse is 1. In examples, 3 times 4, or 3/4 times 4 over 3 equals 1. If we multiplied that out, we would get 12 over 12, and any number over itself is equal to 1. So in algebra, AB times B over A equals 1. And that's if B is not equal to 0, or A, as long as A and B are not equal to 0. You can't have a 0 in the denominator. It's undefined. Examples, find multiplicative inverse. Find the multiplicative inverse of 2/5. Multiply 2/5 by 5/2 to get the product 1. So we get 2/5 times 5/2 equals 1. The multiplicative inverse of 2/5 is 5/2, or 2.5. And that's if we switched the improper fraction 5/2 to a mixed number. Find the multiplicative inverse of 2 and 1/3. So the first thing we need to do is rename the mixed number as an improper fraction, which would be 2 times 3 is 6, plus 1 is 7, so we get 7/3. Then if we multiply 7/3 by 3/7 to get the product 1, because 3 times 7 is 21, so we would get 21 over 21, which is 1. And the inverse of 7/3 is 3/7. Check your progress. Find the multiplicative inverse of 5/6. So multiply 5/6 by 6/5 to get the product of 1. 5/6 times 6/5 equals 1. And the multiplicative inverse of 5/6 is 6/5, or if we convert the improper fraction 6/5 to a mixed number, it's 1 1/5. Find the multiplicative inverse of 1 1/2. So the first thing we need to do is change that mixed number to an improper fraction. 1 times 2 is 2, plus 1 is 3, so we get 3/2. Then if we multiply 3/2 by 2/3 to get the product of 1, remember that 2/3 is the reciprocal of 3/2. So 3 over 2 times 2 over 3 equals 1. And that's because 3 times 2 is 6, 2 times 3 is 6, 6 over 6 equals 1. Multiplicative inverse of 3/2 is 2/3. Find the multiplicative inverse of 8. So we need to rename the whole number as an improper fraction. And we're going to do that by simply placing 8 over 1. Remember that any whole number can be restated as itself over 1. Now we're going to multiply 8 over 1 by 1 over 8 to get the product of 1. And that's because 8 times 1 is 8, and 1 times 8 is 8. So we get 8 over 8, which is equal to 1. The multiplicative inverse of 8 is 8 over 1, is 1 over 8. Find the multiplicative inverse of 4/3. Multiply 4/3 by its reciprocal, 3/4, to get the product 1. So 4/3 times 3/4 equals 1. The multiplicative inverse or reciprocal of 4/3 is 3/4. Scaffolding questions. How can I solve x plus 1/2 equals 5? Subtract 1/2 from each side of the equation. How can I solve x minus 8.4 equals 21? Can add 8.4 to each side of the equation. And how can I solve for 6x equals 54? Divide each side of the equation by 6. In Chapter 3, we learned the addition, subtraction, and division properties of equality. So addition property of equality in words. If you add the same number to each side of an equation, the two sides remain equal. In symbols, if A equals B, then A plus C equals B plus C. And what that means is if I add C to each side, it's going to stay equal. If the two sides are equal and I add C to each side, both sides are still equal. In examples and numbers, 5 equals 5. But if I want to add 3 to each side, 5 plus 3 equals 5 plus 3. So 8 equals 8. In algebra, x minus 2 equals 4. So if I want to add 2 to both sides, I get x minus 2 plus 2 equals 4 plus 2. So if I reduce everything, x equals 6. Subtraction property of equality. In words, if you subtract the same number from each side in an equation, the two sides remain equal. In symbols, if A equals B, so both sides are equal, then I can subtract C from both sides and it will remain equal. In examples, in numbers, if 6 equals 6, I can subtract 2 from each side and they'll still be equal. Algebra, x plus 2 equals 6. So if I subtract 2 from each side, x equals 4. And spoiler alert, x equaled 4 before we subtracted 2 from each side. It's 4 plus 2 equals 6. All right, division property of equality. In words, if you divide each side of an equation by the same non-zero number, the two sides remain equal. In symbols, if A equals B, so if the two sides are equal, and C is not equal to 0, then A divided by C equals B divided by C. And it's important that C is not equal to 0 because I can't divide by 0. It will be undefined. So if A equals B, both sides are equal. I can divide by any number except 0, and both sides will remain equal. So examples, in numbers, if 8 equals 8, I can divide both sides by 2, and it will remain equal. So 4 equals 4. Algebra, 2x equals negative 6. So if those two sides are equal, which it says it is, I can divide the 2 out of both sides, and I find out that x equals negative 3. And it's still equal. Multiplication property of equality. In words, if you multiply each side of an equation by the same non-zero number, the two sides remain equal. And I had you write in on the last 4 things that you had to write on your cheat sheet, the same exact things. Each side and equal. Because I really want to try and drive home the point that if you do the same thing to both sides, then your equation will remain equal. But you have to do the same thing to both sides in order for that to happen. Examples, in numbers, if 5 equals 5, which last time I checked it did, I can take 2, or I can multiply it times any number, as long as I multiply it by both sides, that number on both sides, it will remain equal. So 5 times 2 equals 5 times 2, so 10 equals 10. And in algebra, if I have x over 2 equals negative 3, I can multiply both sides by 2, and it remains equal x minus negative 6. And then if I have 2/3 x equals 4, if I multiply both sides by the inverse or the reciprocal of 2/3, I'll get x by itself. And 4 times 3 is 12, over 2 is 6. So x equals 6. And those values did not change. Each side of both of those equations remain the same throughout because I did the same operation to both sides. And the fraction bar indicates division. So x over 2 means x divided by 2. So the inverse of division is multiplication. And that's why we would do that there. And we know that we multiply the reciprocal of any number to get the product of 1. Solve a division equation. So 7 equals n over 4, or n divided by 4. So write the equation, 7 equals n divided by 4. Multiply each side of the equation by 4. And we're doing that so that we can get n by itself. And if I do that, I'm going to simplify 4 and 4 on the right side. So I get 28n, because 4 times 7 equals 28. And I've simplified the 4 and the 4. I've just crossed those both out because 4 is really 4 over 1. And then I can check that by write the original equation of 7 equals n over 4. And I can replace n with 28 because to the left you see that I said n equals 28. So 7 equals 28 over 4, or 28 divided by 4. And we know that 28 divided by 4 is 7 because 7 times 4 is 28. So we have d divided by 3.5 equals 4.2. And there's the equation. D divided by 3.5 equals 4.2. So I want to get d by itself. So to do that, I'm going to multiply both sides by 3.5. And when I do that, it's going to wipe out on the left side, it's going to wipe out the 3.5 in the denominator. So I get d equals 14.7. Then I can check that by plugging in 14.7 for d in the original equation. And if I divide 14.7 by 3.5, I get 4.2. And is this sentence true? 4.2 equals 4.2, so it is. Check your progress, solve a division equation. 6 equals m over 8. So there's my equation, 6 equals m over 8. Multiply each side of the equation by 8. And I'm doing that so I can get rid of the 8 under the m, the division problem, because that's the inverse, right? If I have m over 8, I'm not trying to get rid of the m, I'm trying to get rid of the 8. So 8 over 1 basically is what I'm doing. And I get 48 equals m. And then I can check that by plugging 48 in for the m. 48 divided by 8 is 6, and that is true. F, I have p over 2.8 equals 1.5. So there's the equation. And I need to multiply both sides by 2.8 so I get p all by itself. So 2.8 times 2.8. And if I simplify that, p equals 4.2. And then g, k over 4.7 equals 2.3. So k divided by 4.7 equals 2.3. So I'm going to write the equation. I'm going to multiply each side by 4.7. And if I do that, 4.7, 4.7, I'm going to get k equals 10.81. Solve a multiplication equation. 3/4 x equals 12/20. So if I write the equation, 3/4 x equals 12/20, I'm going to multiply each side of the equation by the reciprocal of 3/4, which is 4/3. The reciprocal of 3/4 is 4/3. And the reason I'm doing that is I want x by itself. So in order to get x by itself, I need to multiply 3/4 times something that'll give me 1. So it'll be 1x. So I know that if I multiply 3/4 by its reciprocal, I'm going to get 1, and x will be by itself. So then I can multiply 12/20 times 4/3 because I have to multiply it by the same as I do the other side to keep the equation balanced. And if I take out the common factors, and you can stop and go back and look, but I just took the greatest common factor for each one, and I factored out everything. And then if I do the multiplication, I get x equals 4/5. So fractions as coefficients, the expression 3/4 x can be read as 3/4 of x. Remember, the coefficient is the number, or are the numbers that are attached to the variable. So 3/4 multiplied by x, 3x divided by 4, x divided by 4 multiplied by 3. Solve multiplication equations. 1/2 x equals 8. So there's the equation. Probably notice I cheated a little bit because I have the 8 up like I'm going to do something to it. Multiply each side of the equation by the reciprocal of 1/2. So I'm going to go ahead and put the 1 in under the 8 to give you a visual of this. So to get x by itself, I need to multiply 1/2 by its reciprocal so that I get 1. So that's 2 over 1. Then I'm going to multiply 8 over 1 times 2 over 1. So if I divide common factors, I can divide out everything on the left, and that's how I get the 1 beside the x. I can't do anything on the right side of the equation, so I'm going to multiply it out. I get x equals 16 over 1, and then I need to neaten that up and make that x equals 16. So I have 3/4 x equals 9. And there's the equation. So I'm going to multiply both sides of the equation by the reciprocal of 3/4, which is 4/3. Notice that I changed 9 into an improper fraction of 9 over 1 so that we can do this math. And I'm going to cancel out the 4 and the 3's on the left. That's how I'm getting the 1 with the x. And then I can also simplify the 9 and the 3 on the right side this time. So I'm going to get x equals 12 over 1, and I'm just going to make that x equals 12. 7/8 x equals 21/64. Don't let larger numbers get to you. So we have 7/8 x equals 21/64, and I'm going to multiply both sides by the reciprocal of 7/8. So if I get 8/7 times 7/8 and 21/64 times 8/7, I'm going to divide common factors. So on the left side, I'm just going to basically get rid of all those because when I multiply by the reciprocal, it makes it 1, right? So now on the right side, I can do 21 and 7, and I can do 8 and 64. And if I do the multiplication out, x equals 3/8, and I cannot simplify that anymore. Test example. Valerie needs 2/3 yards of fabric to make each hat for the school play. How many hats can she make with 6 yards of fabric? So we are going to, she needs 2/3 yard of fabric for each hat. So given the number of hats, you would multiply 2/3 to find the number of fabric needed. So write and solve the multiplication equation. She has 2/3 n equals 6. And we're going to do the reciprocal. So 3/2 times the left side, and then 3/2 times the right side. And it's going to equal n equals 9 because we canceled out the 3/2 and the 2/3. And then 6 over 1, we could simplify 6 and 2 to 3 and 1. So then 3 times 3 is 9. So the answer is B. And it's a good idea to verify your answer by checking the other answer choices. By doing so, you can greatly reduce your chances of making an error. So you could do that by plugging in 12 for n and 8 for n and 4 for n to see if that equals 6. So 2/3 times 12 equals 6. 24/3 equals 6. 8 does not equal 6. 24 divided by 3 does not equal 6. So choice C, we have the same thing. 2/3 times 8 equals 6. If we multiply that out, is 16 over 3, or 16 divided by 3 equals 6. And hopefully you notice that was not the case, because 5 1/3 does not equal 6. And then choice D, we have 2/3 times 4 equals 6. 8/3 equals 6, but it doesn't, right? 2 and 2/3 does not equal 6. Check your progress. Wilson has 9 pounds of trail mix. How many 3/4 pound bags of trail mix can he make? So each bag needs to be 3/4 pounds. Given the number of bags, you would multiply 3/4 to find the pounds of trail mix needed. So write and solve the equation. So it's 3/4 n equals 9. So if we multiply both sides by the reciprocal, we get 4/3 times 3/4 n, and 9 over 1 times 4/3. If we simplify that, we get n equals 12, and that would be J. Additional examples. Find the multiplicative inverse of each number. So 4/7 is 7/4, or 1 3/4 if we turn it into a mixed number. 6 1/4, we need to turn that into an improper fraction first. So 6 times 4 is 24, plus 1 is 25. So now we have 25/4. The multiplicative inverse is 4/25. Solve the equations. 11 equals p divided by 6. So we're going to multiply each side by 6. We get p by itself, and we get p equals 66. Y divided by 6.4 equals 2.7. So we're going to multiply each side by 6.4, which undoes the division on the left side to get y all by itself. And we get y equals 17.28. 2/5 x equals 6/15. So if we multiply both sides by the multiplicative inverse of 2/5, we get 5/2. That will cancel out the x, or everything with the x, and we get 1x equals 1, because 6 times 5 is 30, and 15 times 2 is 30. So we get 30 over 30 over there. So it's really x equals 1. X equals 30 over 30, x equals 1. And then we have test example. We have Samantha answered 4/5 of the questions on the science quiz correctly. How many questions were on the quiz? C. 4/5. How did we know C? Well, we could multiply the numerator and denominator times a number to try and figure out what would be, like, the denominator, what would be the new denominator. So 4 times 2 is 8, 5 times 2 is 10. So that would mean she got 8 out of 10 answers correct on the quiz. There's your homework. Please head on over to Google Classroom to submit it. I hope you have a great rest of your day, and I will see you in class. Thank you.